Let's take a look at number 36 here at the bottom. So first off, the directions say in the following exercises, find the average value of the function over the given rectangle. I was going to say region, but it says over the given rectangle. So anyways, the way we do this is the definition above here. It says the average value of a function of two variables over a region R is 1 over the area of R times the integral of fxy over the region R dA. So what we're going to do first here is find that area of R. So to do that, I think of the idea of just thinking about my x and y here, bounds, actually on the xy plane. And I can say, hey, this is 1, this is 2, this is 2, this is 3. And I just think of that rectangular region here. And what you see is that this distance here is going to be 1 on the bottom here. And on the left side here, that's also going to be 1 because between 2 and 3 is only a unit of 1. Anyways, knowing that, I know the area of a rectangle is length times width. So this is simply going to be 1 times 1, which equals 1. So the area of R here for us, for this problem, is 1. So really, I'm going to have a 1 over 1 that I'm going to times by my integral. So we're going to start there. So with the a equaling 1 here, we're going to have 1 over 1 times the double integral here. And this f of xy that's here, that's going to be x to the 4th plus 2y cubed. And it doesn't matter our order, so I'm just going to say dx dy. So my dx is going to run from 1 to 2, so I'm going to go 1 to 2. And then my y is going to run from, that's the one we're going to do next, 2 to 3. And then when I do my dx first, that means I'm going to do the inner first because we work from the inside out with integrals. And I'm going to leave that 1 over 1 alone from now on. But I just wanted to show you that for the sake of the formula. Okay, so I have the integral from 2 to 3. And when I do the integral with respect to x here, now remember it's with respect to x, that means that I'm going to end up with 1/5 x to the 5th. Now this 2y cubed is just a constant because I'm dealing with dx. That means I'm dealing with my integral with respect to x. So therefore, that's my constant. Like this whole thing could be like a number 2 or something. So that means I'm going to get plus 2y cubed x. And that's going to run from 1 to 2. And then I still have this dy that I have to deal with afterwards. Okay, so now continuing this, and I'm going to start over here because I have a tendency to run out of room with these integrals. So anyways, so now I'm going to plug in the 2. So that's the integral from 2 to 3 of 1/5. And then instead of that x to the 5th, I'm going to put 2 to the 5th plus 2. And oops, I was just about to put a value in for the y, but the y cubed is my constant here. And my x here is going to be 2. And then it's going to be minus the lower bound when I plug in the 1 for that. So that's what I'm going to do now. Okay, so that's going to be 1/5 times 1 to the 5th plus 2y cubed times 1, and that's going to be the lower bound. Then I still have that dy, and that's this one here that I'm going to deal with after I find this integral. Okay, so that's the integral from 2 to 3, and what I end up with here is, so this first piece here, 2 to the 5th is 32, so I'm going to end up with 32/5 for the first number. And then for the second piece here, second term I should say, not first number, but term. The second term is going to be plus 4y cubed. And then I come over here on this one now. Don't forget the negative, I have to distribute that negative. So those are both going to be minus. So 1 to the 5th is 1 to the 5th here is 1, so, or 1/5, excuse me, but times the 1. So minus 1/5. And then this one here is also going to be a minus because of the negative out here. And that's going to be 2y third, 2y cubed. And then I still have dy. So now I can put all my stuff together here. So I can put the y's together because they're both y cubes. And then I can put the numbers together because they're both numbers. All right, so anyways, equals from 2 to 3. And that's going to give me 31/5 plus, and then that's going to be 2y cubed dy. Okay, now what we're going to do from here is this last integral. We got everything all simplified, so we just do it all over again. So now with respect to y here, this is going to be 31/5 y plus now remember, this is going to have to be a y to the 4th here. So I'm going to have to put a 1/2 here because when I do the derivative here and I bring that 4 down, it needs to be a 2 here. So it's going to be the 1/2. Okay, so anyways, and that's going to be from 2 to 3. So when I plug in the 3 first, that's going to result in 93/5 plus, and then when I do 3 to the 4th, that's actually 81. So that's going to be 81/2. And then I have minus the bottom here. That's when I plug the 2 in there. So that's going to make that 62/5. And then it's going to be plus. Now when I plug in the 2 here, 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to be 16 times 1/2 is going to be 8. And then what we're going to get for a final answer is, so this equals 387/10. So there's our answer for this average value of a function over the given rectangle. So again, we just go by the formula, use it, there it is.